guys. This is our first lesson where we investigate a specific force, okay? And we're going to have at least 2, maybe even 3 lessons on gravity, okay? This is our first lesson, okay? So what is gravity? Okay? We already mentioned gravity, we can call it weight, is the force that the earth pulls us towards it, okay? So all objects on earth, okay, somebody asked me, even germs, even tiny microscopic germs will feel gravity, pull towards the center of the earth. Okay? Why am I saying pull to the center of the earth and not just downward? Because, you know, I'll draw here, okay, if this is the earth, okay, now this is the North Pole, this is the South Pole. Okay? We're standing, let's say, somewhere here in South Africa, we're in the southern hemisphere. Okay? So when we pull towards the end, downward, our downward, what does downward mean? It means in this direction. Where if somebody, let's say in Canada, standing here, okay, his downward is in this direction. So our downwards are in different direction, right? I don't know if when you were kids, you thought like, how come these guys up in the northern hemisphere, they're all standing on their head? Okay, we were always thinking, me living in the northern hemisphere, I thought the people in the southern hemisphere are all standing down, upside down, okay? So weight on Earth, the gravity on Earth is always towards the center of the Earth. I think a lot of you knew that. But I think what many of you, most of you didn't know, that gravity is not just a force between the Earth and let's say the spin. Gravity is a force between any 2 objects. Okay? So the first thing, and this is also you probably never knew that it's true that the Earth pulls this pin downward, but actually this pin also pulls the Earth upward. Okay? Surprising it is, any 2 objects will create a force of attraction between them because of their mass. As much as this pin is pulled by the Earth is also pulled by this pin a little bit. Think about that. Okay, why isn't the Earth moving? Okay, I don't want to say it now. It's a nice discussion that maybe we can have, and you can ask me if you watch this, and we can continue this conversation in WhatsApp with. Okay, that's something that I tell you. This pin also pulls the Earth with the same force, equal force that the Earth pulls this pin. But there's also a force of attraction, a force of gravity between these 2 pins. Okay, so anything that has mass, okay, will attract anything else that has a mass. Okay? Now, why don't I see these pins collapsing together just like, let's say, 2 magnets? The answer is that the force is very, very small. To really see, to observe gravity, to really measure a force, you need to have a lot of mass. How much a lot of mass? Like a planet. Okay? So a planet, I don't know how many kilograms this planet is, millions, shazillions kilograms. Only then you can really measure a measurable force. But saying that, there has been experiments for a long time, for I think 300 years, where they took 2 masses about this, I think what they did something like this. They, I'll draw it for you. Okay. I think it was something like that. Okay. So they took a little rod with 2 heavy masses on it, like a kilogram, and they suspended it. So imagine 2 balls, heavy metal balls, and they suspended that on a string. Okay, on a string. And then, so I'm looking from the top. You see these 2 masses, a little stick between them, and then this string pulls here. Now they took another big mass and they got it close to one of the masses. Now, because there's a force of attraction between those 2 masses, okay, what will happen to this thing? It will twist. This bar will twist. So imagine there's 2 masses here, and I'm bringing another mass which is close. This thing will start twisting towards it, just a tiny bit. And they measured this little twist. They saw that there's a twist, proving that this force exists, even in smaller masses. Okay, so you're going to have to copy that down. I don't know if you want it at the end, at the beginning. But force, what is gravity? It's a force of attraction. And this is important to know. It's always an attractive force. We're going to look at magnetic, electrostatic force later, that they can also be repulsive forces. Gravity, what's unique about gravity, what makes gravity fascinating, that it's always an attractive force. It's a force of attraction between any two objects. Any two objects, not just the Earth and me, okay, but actually two pens as well. Two germs, two cells, two plant cells will have a force of attraction, tiny one, okay, between any two objects due to their mass. It's their mass that create this attractive force and their distance between the two objects. So the further away the two objects are, the smaller the gravitational force. Okay? When I'm standing on Earth, the gravitational force here, okay, I will talk about that later, it makes more sense, is 9.8 Newton per kilogram. Whatever that means, we'll talk about that next lesson. Okay? But if I go up 100 kilometers away from the Earth, fly up in the airplane or in the spaceship, that gravitational force is now less. Okay? The further away I go from the Earth, the gravitational force on me will be less and less and less, until when I get to a specific place which is far enough from the Earth, then I'm on zero gravity. I won't feel that gravitational force. Okay? So the gravitational force between two objects depends on their masses. More mass, the more gravitational force there is, and the distance. The less distance, the more force there is. Okay. Right. Now, that's the first thing I need to guys to do, and copy that. And now we're going to talk about something which is very confusing, and that's the difference between weight and mass. Okay? We slaughter these concepts when we talk about day-to-day. Okay? Slaughter, we're not using them properly. Okay? Often I'll say, my weight is 70 kilograms. No, that is actually wrong, as we will see now. What is the difference between weight and mass? Just pause me now for a second. Just tell yourself, what is the difference between weight and mass? Okay, so it turns out, let's start with mass. Mass, I don't really have a good definition for it right now. Okay, I'm only going to be able to define that for you maybe in 2-3 years. But for now, we'll say mass is how much matter there is, how much stuff there is in that object. So I can say there's 20 grams on this, or 500 kilograms. It's to do, you can imagine, with how many atoms there are, but also how many protons and neutrons and electrons there are in those atoms. Because some atoms have less protons and neutrons. So mass is how much stuff there is inside. Okay? We measure mass, I said in kilogram. We can also measure in grams and milligrams, but kilogram is our main unit. And the mass of an object can change only if we change the object. So to change the mass of this pen, I can remove the cap, I can cut it in half, or I can add another plasticine or press stick on it or whatever. I have to change the object to actually change the mass, okay, which is obvious, okay? Weight is a different story. Weight is a force. First of all, it's a force. Okay? It's not how much stuff there is, it's the force that this object is pulled towards the center of the Earth. Now, if it's a force, then it's not measured in kilogram, it's measured in Newton. All forces are measured in newtons, we said last time. And the weight of an object can change without changing the object. Okay? If I want to change my mass, either I need to eat a lot, okay, or I need to lose mass, okay, right? Maybe go on a diet, or maybe even I'm really desperate, just cut an arm off, then I'll have less mass. But there is a way of changing my weight without changing anything in my body. Okay? How do we do it? I'm not a magician, okay? Remember, a weight is the force that pulls us towards the center of the Earth. How can I fiddle with that force? Well, one thing is already mentioned, I can move further away from planet Earth. I can go onto a spaceship, fly 1,000 kilometers up in the air towards already space. It will go dark outside there, this kind of bluish dark like you see in the movies. My weight will be less. Okay? If I go away from planet Earth and go to the moon, land on the moon, you can see these people walking there. I'm sure you saw Buzz Aldrin and what's his name, okay, walking on planet Earth on the moon like this. They jump and you go, woo, okay? Why is that? Why does it take them so long to actually fall down? Because their weight is much less. The gravity, the weight that they're pulled towards the center of the moon is less than on planet Earth. It's 6 times less. So if I was lucky enough to go to the moon, okay, my weight will be 6 times less than it is on planet Earth. Okay? Now, most of us are not going to get to the moon. We're not even going to go on a spaceship 1,000 kilometers up. We're not going to probably do it, but there's still an easy way, much easier way to decrease our weight. And that's simply by submerging ourselves in water. When you jump into the pool, I'm sure you've done it, okay? You can carry your buddy. Okay? You can carry your friend who maybe is even heavier than you. You can carry him in his arms. Could you do that outside of the pool? No. You're going to crash down. Okay? You're going to hurt your friend and maybe yourself. But in the pool you can. Why? Because your friend's weight is less. Okay? Gravity still pulls him down, but because there's upthrust from the water that pushes him up, his weight decreases. So weight can change in different planets, or if you submerge in liquid, okay, where the mass of an object only changes if you actually change the object itself. So now please copy this down, pause me and copy this down, and I'll see you next lesson.